All right, welcome to the deep dive. Today we're going to take a look at, well, honestly, it's kind of a big one. Meta's just come out with their brand new Llama 4 family of AI models, large language models. And I know a lot of you out there are just like me. You want to figure out quickly like what's actually important here without having to wade through a ton of like super technical jargon.
Mm.
So that's exactly what we're going to do today in this deep dive. We've gone straight to the source. We've got Meta's official announcement here, and we're going to pull out, hopefully for you, the most interesting and important parts. What is this Llama 4 thing? What makes it different? And why should you care?
Yeah, I mean, reading through the announcement definitely seems like a really big step forward, especially with what they're calling natively multimodal capabilities. It's not just like a small improvement. This sounds like something that's like really changing how these models understand the world.
Okay, so natively multimodal, that's a phrase that jumps out right away. Can you break that down a bit? Like, what does that actually mean for how these new Llama 4 models work compared to
Yeah.
what came before?
Well, think of it like this. Older AI models, they might have been trained mainly on text, right? And then maybe later on they figure out a way to like kind of tack on the ability to handle images almost like it's a separate thing. But with this natively multimodal thing, what it means is that like two of these new models, Llama 4 Scout and Maverick, they were designed from the very beginning to understand both text and visual information at the same time. Like it's all just one seamless thing. It's much deeper than just adding it on afterwards.
Gotcha. Okay. So it's not like two separate streams of information that have to like come together later. It's all kind of baked in from the start.
Yeah, exactly. And this really like unified approach leads to this other really big thing, which is that they're able to support much longer context lengths than ever before. That's like, you know how much information the model can actually keep in mind when it's trying to generate a response. So it's kind of like it's working memory and they've basically supercharged it.
Okay, so let's start with the first of these new models, Llama 4 Scout. What are some of the like headline features that make this thing interesting?
Okay, so Llama 4 Scout has 17 billion active parameters and uses an architecture with 16 different experts. Now, the number of parameters, that kind of gives you a sense of its size. But what's really interesting is that Meta claims this is the best multimodal model in the world in its class.
Okay, so in its class, what does that actually mean? Is it talking about the size of the model or like the computing power it needs?
Or something else. Yeah, it's probably a combination of factors, but what they also make sure to point out in the announcement is that Llama 4 Scout is efficient enough to run on just a single, like a high-end NVIDIA H100 graphics card. So what that means is that it's really powerful, but you don't need like a giant server farm to use it. But don't let that fool you into thinking it's not powerful. It's actually got this massive 10 million token context window. Like to give you an idea of how big that is, imagine being able to keep the entire text of like several really large books in your head all at once. That's kind of what we're talking about here.
Wow, 10 million tokens. That really puts things in perspective. They also mentioned it performs really well against some of the other leading models out there. Like, who are they saying that Llama 4 Scout beats?
Yeah, so they're claiming it actually gets better results than models like Gemma 3, that's from Google, and also Gemini 2.0 Flashlight and Mistral 3.1 on a whole bunch of industry standard tests and benchmarks. So that seems to indicate that it's a real step forward compared to what else is out there in a similar kind of size category.
Okay, so what's the secret sauce here? What's allowing them to get this level of performance, especially with this crazy long context window?
So what they highlight in the announcement is that they actually trained Llama 4 Scout on sequences of up to 256,000 tokens. And they did that both during its initial pre-training phase and also during the later fine-tuning. So basically giving it a ton of experience with these long, long sequences of information. They also mentioned that they're using this new thing they call IRO-EE, which stands for Interleaved Attention Layers Without Positional Embeddings. And also they use temperature scaling of attention during inference. All that stuff basically means they found these really clever ways to help the model understand how different pieces of information are related to each other, even if they're super far apart in the input.
Okay, so this IROB-E thing, that sounds pretty technical, but can you just like simplify that a bit?
Sure, so think about it this way. When a language model is trying to understand text, it needs to know not just the words, but the order that those words come in, right? And traditionally, they've used these things called positional embeddings to basically keep track of that order. But this IRO-PE thing, this is a different approach that seems to be more flexible and more efficient when you're dealing with these really long sequences. And the interleaved attention and the temperature scaling, those are kind of like the fine-tuning knobs that help keep the model on track, even when it's dealing with these huge amounts of information. Make sure it doesn't get lost in the weeds and stays focused on the main point. And one more thing that they mentioned that's really impressive about Scout is that it has like best-in-class image grounding capabilities. What that means is it's really good at actually connecting the things that it sees in an image with the relevant words in a text prompt.
Okay, so that gives us a good picture of Llama 4 Scout. Let's move on to the next one, Llama 4 Maverick. What's different about this one?
So Maverick also has 17 billion active parameters, just like Scout. But it uses a much, much larger number of experts, 128 to be precise, in this thing called a mixture of experts architecture, or MOE for short. And they're also calling this one the best multimodal model in its class.
Okay, so same number of active parameters as Scout, but a huge jump in the number of experts. What's the advantage of using this MOE approach?
Well, imagine if you had like a team of specialists, each one with deep knowledge in a very particular area, and MOE model works kind of like that. When it gets an input, only a small group of those expert networks actually get activated, just the ones that are most relevant to the specific task. This way, it can actually have much larger overall capacity for knowledge, more specialized knowledge, but it doesn't need to be crunching numbers with all of them for every single question.
Oh, I see. So that's a great analogy.
Yeah.
So in terms of performance, how does Maverick actually stack up?
Well, according to their announcement, Maverick actually outperforms even bigger models like GPT-4o and Gemini 2.0 Flash and a whole bunch of these benchmarks. But what's really interesting is that they also say it gets comparable results to the newer and much larger DeepSeek V3 model, especially on complex tasks like reasoning and coding. And it does that while using significantly fewer active parameters.
Okay, so that's actually pretty amazing. Getting similar results to a much bigger model while using less resources. They also mentioned that Maverick has this really good performance to cost ratio. What does that mean in practice?
Basically, it means that you're getting really top-tier performance without needing a ton of expensive hardware to run it. They even mentioned that there's this experimental chat version of Maverick that got a really high score of 1417 on this thing called Llama, which is kind of like a leaderboard for language models. So all that seems to point to the idea that you can get a lot of bang for your buck with this one.
So how does Maverick manage to be so efficient? Is it just because of the MOE architecture, or is there more to it?
Well, they highlight in the announcement that they use these alternating dense and MOE layers within the architecture, and that that's specifically designed to make it really fast and efficient during inference. That's like when it's actually generating the responses. This design actually lets it run on just a single NVIDIA H100 DGX host, so it's actually pretty accessible. And then they also go into detail about the post-training process for this one, which was pretty sophisticated. So they did some really careful fine-tuning with selected examples, and then they used reinforcement learning to further improve the responses. And then finally, they did something called direct preference optimization, which is basically making sure that the model's outputs align with what humans actually prefer. And all of that, including that multi-stage post-training with the focus on those more difficult examples or prompts during the reinforcement learning, that seems to be a big part of why it's so good across all these different kinds of tasks.
That post-training process sounds pretty important for getting these models to really sharpen their skills. That focus on the hard prompts during reinforcement learning is really interesting.
Yeah, absolutely. By training it on tougher problems, they're basically forcing it to develop these more robust and generalizable skills rather than just memorizing easy patterns. The way they did the online reinforcement learning with the adaptive data filtering sounds like that was a really important part of making sure that the training stayed efficient. And the result, as they say, is that it's got really strong performance across the board. Understanding images and text, coding, reasoning, handling multiple languages, and being able to deal with these long sequences of information, it seems to do it all.
Okay, let's move on to well, honestly, the big one here, Llama 4 Behemoth. The name kind of says it all, I guess.
It does, yeah. So Behemoth is described as having a massive 288 billion active parameters and almost 2 trillion total parameters using 16 experts. And they really emphasize that this is their most powerful language model to date. which would put it among the most capable AI systems that exist right now.
2 trillion parameters. I mean, that's a whole other level compared to Scout and Maverick.
Yeah.
So for a model that big, what kind of performance are we talking about?
Well, they actually claim that Behemoth outperforms even some of those big names that we all know about, like GPT 4.5, Claude Sonnet 3.7, and Gemini 2.0 Pro. And they did that on a bunch of those really tough STEM benchmarks. So it looks like it really is at the cutting edge of what's currently possible.
So if it's that powerful, why aren't they releasing it right now along with Scout and Maverick?
Well, it's interesting because the announcement says that Behemoth is still being trained, but the main thing they're using it for right now is to act as what they call a teacher model for Llama 4 Scout and Maverick. And they specifically mention this process called co-distillation and also this new kind of training loss function.
A teacher model. That's a really interesting concept. So basically, they're using this giant behemoth model to help the smaller, more efficient ones learn more effectively.
Yeah, exactly. So this co-distillation process, it's basically about transferring the knowledge and skills of the larger model to the smaller ones. It's like one of the main reasons why they're able to achieve such high performance, even though they are, relatively smaller in size. And this new loss function that they developed, it's probably helping them to make sure that the smaller models are learning the most important aspects of the teacher model's knowledge. So it's kind of like a more targeted, more efficient way of transferring that information.
Okay, what about the challenges of actually training a model that big? I mean, the announcement touches on that briefly.
Yeah, so post-training a model with like 2 trillion parameters is a massive undertaking. They mentioned that they actually had to completely redo a lot of their training methods, including things like aggressively filtering their fine-tuning data. They actually cut out up to 95% of it for Behemoth, just to focus on the absolute highest quality examples. They also found that doing large-scale reinforcement learning after that initial fine-tuning led to some big improvements in the model's reasoning and coding abilities. And the way they did the reinforcement learning was interesting too. They were very deliberate about choosing those hard prompts and then dynamically filtering out the ones that weren't that useful as the training went on. They actually had to rebuild parts of their reinforcement learning infrastructure to handle a model this big, and it ended up making the training way more efficient.
Okay, so we've covered the 3 main models, Scout, Maverick, and Behemoth. Let's dive into the technology behind all of this. What are some of the key innovations, like in the architecture or the training process, that they highlight in the announcement?
One of the things that keeps coming up is this mixture of experts architecture. Like we talked about, it's used in both Scout and Maverick, and it really seems to be key to making these models so efficient, both when you're training them and when you're actually using them. Another really big innovation is this native multimodality thing. So that's basically achieved through early fusion of the text and vision data into a single model architecture. That's pretty different from older ways of doing things where often different types of data were processed separately.
Early fusion. So it sounds like the model is really processing the text and images together right from the start, like at the deepest level.
Exactly. And that allows it to build this much richer, more nuanced understanding of how these different types of information are actually related to each other. They also made some big improvements to their vision encoder, which is based on their Meta-CLELIP model, but they trained it even further to make sure it works really well with the language processing parts of the model.
Any other technical details that stand out? They mentioned this Meta-P thing.
Yeah, so Meta-P is this new training technique that they developed to help set those crucial training parameters, things like the learning rate and how the model's initial weights are set. And they actually found that the settings they determined using Meta-P work really well across different model sizes and training setups. It really streamlines the whole development process. And something else that's worth noting is the amount of multilingual data that they used in pre-training. It covers something like 200 languages and has way more data per language compared to Llama 3. So that should translate to some pretty big improvements in languages other than English.
That expanded multilingual data is really important for making these models useful for people all around the world. What about the efficiency of the training process itself? Were they able to improve that?
They definitely put a lot of emphasis on training efficiency. So they used this thing called FP8 precision during pre-training, which allowed them to get these really high throughput numbers. They mention an impressive 390 teraflops per second per GPU for Behemoth. And that kind of efficiency is absolutely crucial when you're dealing with models of this size. And then, of course, the size of the pre-training data set itself is huge, over 30 trillion tokens, more than double what they used for Llama 3. That includes a vast variety of text, images, and video data. And they also mentioned some of the mid-training techniques that they used, and also the special data sets that they created to push those context-length capabilities even further.
Okay, with all this power comes the question of safety and safeguards. What did they do on the Llama 4 models to address that?
They definitely emphasize their commitment to developing safe and helpful AI models, and they lay out a really multi-layered approach to how they're trying to do that. So that includes being really careful about filtering the data that they use for both the pre-training and the fine-tuning phases, making sure that they're not including anything harmful or inappropriate. And they also developed this whole set of system-level safeguards that developers can use to basically make sure these models are used safely in their applications.
Could you give some examples of these system-level safeguards?
Yeah, so they highlighted this thing called Llama Guard, which is basically like a safety model. And it can analyze both the prompts that you give the AI and the outputs that it generates. And it does that based on like a defined set of safety guidelines. So developers can use that to basically see if either the inputs or the outputs are violating their application policies. Then there's Prompt Guard, which is specifically designed to spot those potentially malicious prompts, like somebody trying to trick the AI into bypassing its safety measures. And then they have this CyberSecEvil tool that helps developers understand and manage any potential cybersecurity risks that come with using generative AI. And what's really great is that they're making all of these tools open source and customizable, so developers can really tailor them to their specific needs and contexts.
Making those safety tools open source seems like a really good way to get the community involved and be more transparent about what they're doing. What about their internal testing? How do they make sure that these models aren't going to do anything harmful?
They actually describe a pretty rigorous process of testing. So they do all these systematic tests across a whole bunch of different scenarios, and they use techniques like adversarial dynamic probing, including both automated testing and human testers, to really stress test these models and see if they can find any weaknesses. They even created this new tool called JO8, which stands for Generative Offensive Agent Testing. And this tool basically simulates these multi-turn interactions with like malicious actors to really find those vulnerabilities and figure out how to fix them. It's kind of like an automated red team that helps their human red team focus on those really new and complex risks.
Okay, so finally, let's talk about how these models are being released to the world. Who gets to use them?
Yeah, so with Llama 4 Scout and Maverick, they're really pushing this open approach. You can actually download them right now, starting today, on their website, llama.com. They're also on Hugging Face, which is this popular platform for AI developers. But what's really interesting is that they're also building them directly into Meta AI across all their different platforms: WhatsApp, Messenger, Instagram Direct, even on the web. So that's going to let everyday people experience what these new models can do firsthand. And they also announced this long list of partners across the AI ecosystem that are supporting the Llama family. It seems like a really big collaborative effort.
So to sum it all up, it seems like this Llama 4 family, especially those Scout and Maverick models, are a big leap forward. They've got this new ability to understand text and images natively, those incredibly long context windows, and they seem to perform really well compared to other leading models, all while being surprisingly efficient. And then you've got this behemoth model, this giant teacher model, that's really pushing the boundaries of what's possible.
Exactly. And hopefully this deep dive, going right to Meta's own announcement, has given you a clear and easy to understand overview of what all of this means without bogging you down in too much technical jargon.
Yeah, absolutely. So as you think about all of this, consider just how big of a deal this is. I mean, we're talking about AI that can not only understand both text and images like it's second nature, but also remember and process these huge amounts of information. How is that going to change the way we interact with AI, use AI in the very near future? We encourage you to check out the resources that we mentioned, llama.com, Hugging Face, Meta AI. Go explore, dive in, see what this new era of AI is all about. Thanks for joining us on The Deep Dive.